Have you ever wondered why the top of the Burj Khalifa swings? Let's discover the amazing engineering that's behind it. The spire at the top of the Burj Khalifa, even though it might appear small, plays a crucial role in the building's stability. While the general public isn't allowed to visit it, and the floors within it aren't heavily used, its presence is essential to ensure the overall structural strength of the entire tower. The engineers had to build this spire because it was necessary for the building's stability, and they had to make sure it was completed no matter what. Interestingly, this spire is not to be underestimated. It's like a skyscraper all on its own. In fact, its height matches that of many standalone skyscrapers found in various countries around the world. The spire is constructed from a massive 4,000 tons of steel and reaches a height of 244 meters. The Statue of Liberty in New York City is about 93 meters tall. If you could lay down 2.5 statues of Liberty end to end, that would be roughly equivalent to a length of 244 meters. Additionally, the top of the spire features an antenna that weighs 350 tons. It's worth noting that if the entire spire were somehow removed from the Burj Khalifa, the building's height would be reduced by a significant 30%, bringing it down to 585 meters. To put that in perspective, this is the same height as the last accessible floor, which is the 154th floor. The Burj Khalifa has a total of 163 floors. Visitors are allowed to access the observation decks on the 124th and 148th floors of the Burj Khalifa. However, the remaining floors are not open to the public. The spire begins just above 154th floor and extends all the way to the very top of the Burj Khalifa. Inside the Burj Khalifa, floors from 155 to 163 have been constructed. However, it's surprising to learn that these floors are not suitable for habitation. This is because the entire spire of the building has the remarkable ability to sway up to 6 feet during strong winds. This swaying is not a flaw but actually an intentional and advanced feature of the spire. The location of Dubai poses a unique challenge due to its surroundings: the Arabian Gulf on one side and the Gulf of Oman on the other. Dubai experiences fast and strong sea winds as a natural occurrence. At the towering height of the Burj Khalifa's top, wind gusts can easily reach speeds of up to 240 kilometers per hour. To counteract the immense pressure from these high-speed winds, the spire of the Burj Khalifa is designed to absorb the force by moving up to 6 feet. This movement serves to safeguard the 154 floors situated below the spire. The credit for this innovative design goes to American structural engineer William Baker, who came up with a revolutionary approach. Instead of trying to block the winds, Baker's design confuses the winds, allowing the spire to sway and absorb the forces while maintaining the stability of the building. When high-speed winds collide with the Burj Khalifa's structure, they create energy that needs to be managed. The building's 154 floors are connected through a main buttressed core. However, if the generated energy were to flow into this core, it could potentially cause cracks in the concrete. To prevent this, the spire isn't linked to the buttressed core. Instead, it's constructed using steel, a flexible material. Steel is chosen because of its flexibility. The energy produced by the wind is absorbed by the steel structure of the spire. This allows the energy to be released into the steel, causing the top of the Burj Khalifa to sway. Engineers have carefully planned the swaying to be restricted to a maximum of 6 feet. The spire of the Burj Khalifa serves two important functions. It handles the building's swaying due to wind and, secondly, provides protection against lightning strikes for Dubai. At the top of the world's tallest skyscraper, there's a lightning arrestor device. This device has a sensor that detects electrical charges in nearby clouds. The lightning arrestor plays a crucial role by generating an opposing electrical charge that attracts lightning towards itself. This way, the lightning is directed away from the building. Using steel wire, the arrestor safely guides the charge, which can be millions of volts strong, down into the ground. This process effectively protects the entire building from the potentially devastating effects of lightning strikes. The strategic placement of the lightning arrestor on the spire is significant, being situated at the highest point compared to surrounding structures. The arrestor not only safeguards the Burj Khalifa but also extends its protection to the entire city of Dubai. This is particularly important given the frequent occurrence of lightning strikes carrying hundreds of millions of volts of current. The lightning arrestor has shown its effectiveness by successfully fulfilling its role in 16 to 20 lightning strikes. After each strike, a small battery within the arrestor requires replacement, a task that involves a trip to the top of the spire. In Dubai, sandstorms and strong ground-level winds reaching speeds of up to 100 kilometers per hour are common occurrences. Tall skyscrapers like the Burj Khalifa face significant challenges due to these strong winds. In Midtown Manhattan, close to New York City, the Citigroup Center stands at a height of 279 meters. However, a significant engineering flaw was discovered in its design after its completion in 1978. A student studying engineering at Princeton University noticed that the building wasn't adequately designed to withstand the forces of strong winds. It was determined that around 25% of the wind gusts could potentially cause the Citigroup Center to collapse. When this information reached the building's designers, they immediately made some calculations and agreed with the engineering students' observations. It is said that, keeping this matter confidential, extra dampers were added to the building in the name of maintenance. This information was kept confidential and was not disclosed for a number of years. When powerful winds strike a building, they create rotating air patterns on the building's rear or back side, known as vortices or rotors. These vortices are areas of low air pressure that cause the building to shift sideways. Even a small initial movement of the building can result in a notable increase in sideways motion. This happens because of the amplifying effect of these vortices. The most perfect example of this can be seen in the swing at a park, which perhaps all of you have swung on at some point. When you synchronize the movement of your legs with the swing's motion while swinging, we can make the swing move higher and faster. This is because we are moving our legs with the frequency of the swing. This phenomenon is called resonance. In the case of the world's tallest building, the Burj Khalifa, structural engineer William Baker designed a configuration that naturally disrupts wind patterns. If you closely observe the Burj Khalifa's structure, you'll notice that all the decks of the Burj Khalifa are not built at the same level as each other. Rather, they have been designed asymmetrically, meaning each deck is different from the others. This intentional asymmetry has a specific purpose. When the wind impacts the Burj Khalifa, it creates spinning air patterns behind each floor. These rotational patterns vary on each floor due to the non-uniform design, meaning their frequencies don't match the tower's frequency. This is the reason that the world's tallest building has been able to withstand strong winds by confusing them and has remained structurally sound for the past 13 years. Whether the wind comes from the north or the south, the design of the Burj Khalifa confuses the air from all directions. Typically, before beginning any construction project, a comprehensive design plan is established. But during the construction of the Burj Khalifa, no one knew how tall this tower would go. Initially, the projected height was 530 meters. This height was decided in 2003 when construction on the Burj Khalifa started. At that time, another skyscraper called Taipei 101 was in its final construction stages, and its height was set at 508 meters. To do even better than that, the Burj Khalifa was initially intended to reach 530 meters. But later it was thought that anyone could easily break the world record of 530 meters. So during the construction of Burj Khalifa, the developers, Emaar Properties, kept the world in confusion until the very end. Back in 2003, it was reported that Burj Dubai, which was the first name of Burj Khalifa, will be 530 meters high. In 2004, the announcement was made for a height of 570 meters. In 2005, it increased to 710 meters. In 2006, the plan was raised to 800 meters. And then again in 2006, a height of 818 meters was mentioned. And finally, in 2009, when the construction was completed, its height was 828 meters. It was for this reason that other projects, higher than Taipei 101, proposed during the construction of the Burj Khalifa, could never claim the title of world's tallest building. The ups and downs in the height of the Burj Khalifa also caused money problems for the company in charge of the project, Emaar Properties. The money they had set aside for building was running out fast because the tower was getting taller than they first thought. This financial problem became so severe that construction had to be stopped. Then Abu Dhabi's ruler, Sheikh Khalifa bin Zayed Al Nahyan, funded the project and revived it. That was the point when the name of the Burj Dubai was changed to Burj Khalifa. After Burj Khalifa, several projects were announced in the race to claim the title of the world's tallest building, and construction began on those projects as well. However, there is still no chance that this title will be taken away from Dubai. The construction of Saudi Arabia's Jeddah Tower has been stalled for the past several years. Kuwait has planned to build a 1-kilometer tall building named Burj Mubarak, but there has been no update after this planning. Even Nakheel Properties had launched a project in Dubai named Nakheel Tower, whose height was being reported to be more than 1,000 meters. In 2009, its construction also began, but the project was stopped the very next year. The total cost spent on the Burj Khalifa was around $1.5 billion. Today, thousands of tourists visit the Burj Khalifa every day, if calculation is done based on the average entry fee. Then in just 1 year, Burj Khalifa is earning more than $1 billion by selling entry tickets alone. The positive economic growth that happened in Dubai due to this is indeed phenomenal. I would greatly appreciate it if you could consider liking, sharing this video, and subscribing to the channel.